Hi, I'm Guy. I'm in the Azure Compute team. This session is an introduction to virtual machine scale sets. So, what are virtual machine scale sets? Well, at a high level, virtual machine scale sets are a way to deploy and manage a set of identical virtual machines. So with Azure Infrastructure as a Service, if you want 50 virtual machines, you normally have to think about your networking, your storage, your extensions. You have to think about the underlying infrastructure and how you configure these virtual machines, and you generally have to think of them as individual virtual machines, even if you create them as a loop. Virtual machine scale sets gives you a way to just be able to say, I want 50 virtual machines, and then just configure the properties and manage them as a set. Scale sets also integrate with Azure Autoscale. What that means is you can dynamically grow and shrink the pool of virtual machines that you have. So if you want to scale up, you can just change the number of virtual machines. If you want to scale down, just set a lower capacity. And then if you want to be able to integrate it with operating system events such as CPU use, average CPU usage, you can easily integrate that using Azure Autoscale. Scale sets also integrate with the Azure Load Balancer. What that means is you can set up a group of VMs as, for example, a backend web server and have Azure Load Balancer round robin the connections, or you can set inbound NAT rules so you can map port per port from incoming connections to your backend pool of virtual machines. Another way to look at scale sets is an Azure Compute resource as part of Azure Resource Manager. I'll talk a little bit more about Azure Resource Manager as we go through how to build a virtual machine. But as an Azure Compute resource, it's a resource called Virtual Machine Scale Sets under Microsoft.Compute. Also under Microsoft.Compute you have virtual machines, so it sits at the same level as virtual machines. Another way to look at scale sets is it's a scalable compute layer for hyperscale applications. What that means is if you have a large scale application with multiple components, perhaps it uses microservices, it has different areas that you configure, you can use scale sets to be a generalized compute layer where you have a set of identical virtual machines that can take compute tasks, it can scale up, it can scale down to suit your needs. So it makes it very easy to put in that kind of compute layer into your large-scale applications. And in a similar vein, you can use it as an infrastructure for platform as a service. So scale sets, really it's a infrastructure as a service, but it's a way of managing a group of virtual machines which make it easier for you to deliver a PaaS service on top of that. And you'll see that some of our PaaS services such as Batch and Service Fabric will be building on top of this, and it also integrates very nicely with third-party orchestrators and cluster managers. Here's an example, kind of a high-level diagram of our Azure's next generation cloud platform, and here you can see how scale sets fits into the overall hierarchy. It's kind of simplified, but at the bottom you can see that with Azure Stack, you can also deploy Azure binaries on premises as well as in the public cloud. And then virtual machine scale sets can just sit on top of Azure Stack or Azure public cloud. And then virtual machine properties such as extensions, which we'll look at briefly, can then run just as well on top of virtual machines or on top of scale sets. You can integrate with third-party PaaS layers, like Marathon, for example. You can cluster orchestrators, as I mentioned, Mesos Swarm, Scalar, RightScale, and then first-party and Microsoft PaaS services like Batch and Service Fabric, and then higher-level services which can then build on these PaaS layers. It all fits in, and scale sets fills a gap in a way between configuring virtual machines and being able to configure a scalable set of virtual machines. So let's look at how to build a virtual machine scale set. And before I do that, why don't we just take a detour and go and deploy a scale set and see how that looks. So I will go to GitHub and I'll go and deploy a scale set, and I'll talk about a little bit more about how it's built after I've deployed it. So this repo, it's a public repo. Azure Myriad has a set of, as we develop templates that deploy scale sets, we generally put them here first. So let's go take a look. I'm going to deploy this scale set, which creates a virtual machine scale set with a load balancer, with a public IP address, and with a set of inbound NAT rules. So let's just go deploy it, and then I'll go into more detail about some of these scenarios that it then uses. So when I click the Deploy to Azure button, that's really just a link to the Azure portal. So I go to, this takes me to a custom deployment section. So this template, then what happened there is the template is read, and parameters that we define in the template, and I'll be going through a template in detail, so this will actually explain what I'm doing, but I'm doing it first so that then we can go in later and see how it's running. So I'm going to give it a name. I'll just call it NatPools2 and give an instance count. Let's create 5 instances. Going to give it a unique storage account name. It's actually going to create a set of storage accounts. So, but it's going to add letters to these values, but I'll just put this in, and I'll give it just a username so I can connect as needed. So that's my set of parameters. I'm going to use my subscription. I'm going to create a new resource group for this. That way, if I want to delete or update my resources, I've got them all together for this template in a resource group of its own. So I'll create a new resource group. I'll use this location Southeast Asia, and then the legal terms, which I'm sure everyone reads very thoroughly. I'll click Buy, and then I'll go and create the scale set. So while that's creating, I'll go back to the slides, and we'll come back and visit this later. So I glossed over all the details, what this scale set, what this template was, so now let's look in more detail. And the way to start with that is, let's have a quick review of how you build a virtual machine in Azure Resource Manager. So you start by defining or declaring a resource group, and then within that resource group, if your virtual machine needs a public IP address, you declare one of those, and you create a VNet with a subnet. You create a storage account, or you can use an existing one, and then using the public IP address and the VNet, you define a network interface. Then you can define your virtual machine, which depends on the network interface card and the storage account. So that's how you build up a single virtual machine. It has a set of dependencies. We have a whole bunch of examples in Azure Quick Start templates in GitHub. So what about resource loops? Here, if you want to create a set of virtual machines, you can do it in a loop, and I'll explain what the difference between using resource loops and scale sets is. But with a resource loop, it's a kind of, you could think of it a little bit like a for or a while loop. You can just loop around as many times as you want. So you can, if you're going to, instead of creating one virtual machine, one network interface, one public IP, you could do this in a loop, and you'd have a separate loop for each resource, and then you need to correlate these resources. So you can keep going, and you can loop other things like, you could create multiple subnets, you could create multiple storage accounts, etc. And we have some examples of these. I've just shown a link here to, again, in Azure Quick Start templates. So you can use this to create a bunch of virtual machines. So why would you need something like scale sets? Well, there are some challenges if you're creating large numbers of virtual machines. If you're using resource loops, you then, as I mentioned, you have to correlate these loops of independent resources. So your NICs, your storage accounts, your virtual machines, you can have different numbers of storage accounts to virtual machines, for example. You could have up to 40 disks in a storage account. How do you scale up or down? Where do you place the virtual machines? If you add virtual machines, if you take virtual machines away, there isn't an easy mechanism to do auto scale in a balanced way that's going to be use different fault domains or update domains. So it doesn't make it easy for you. And then similarly, as you scale up, how do you ensure availability across domains? It's not something that's taken care of automatically. You actually have to think carefully about it. So resource loops really, they're a syntactical shorthand for defining multiple resources in Azure Resource Manager, but you will still have multiple calls. A call for each resource in the loop will go down to the fabric. So it's really, you could think of it as a kind of shorthand. So scale sets, for scale sets, if you're defining one, you start the same way. You define a resource group, you define a VNet, you define a subnet. But then you define your scale set and you say how many virtual machines you want, and that's known as the capacity. And we'll look at what a template for that looks like. So you say how many virtual machines you want. You define the virtual machine properties, but they're all going to be the same. You could think of it as the pets versus cattle analogy, where if you have virtual machines with different functionality in your application, you could think of them as pets and you define individual VMs. But if you have a set of virtual machines with the same functionality, basically configured the same, then you can think of them as cattle and you can manage them as a set. So you define your virtual machine properties, you define your network properties, you can define your storage properties, you can define extension properties for the set of virtual machines as a whole. This makes it much more straightforward to configure and to manage. Now, because it builds on Azure Resource Manager, unlike, for example, worker roles, you can use both Windows and Linux virtual machines, and you've got the full range of VM extensions. And you could think of it as an open platform for platform as a service. And with since your main focus is just what the number of virtual machines is, the target instance count or the capacity, it's a lot easier to manage this way. This is what it'll look like in a template. So if I define my resource using the JSON-based template language that Azure Resource Manager uses, I've highlighted in red the capacity. And in this case, I like, for example, if you take you could pass it in as a template parameter. This is how many virtual machines that I want. And then for when you're configuring the virtual machine properties, instead of defining a computer name, you define a computer name prefix. So this is every virtual machine I create is going to start with this name. So it's going to be like myVM_0, myVM_1, etc. as you create this set. So if you're scaling up and down, all you really have to do is change this capacity value. So you can just deploy a much more simple template which varies this capacity number, and then therefore you can do whatever scaling up, scaling down that you need. You could also manually remove specific virtual machines if you want, and that actually provides ways of doing updating your VMs progressively. So let's go through a few basic scale set scenarios. These are kind of typical patterns that you may use virtual machine scale sets for. Perhaps the most straightforward is how do you connect to your virtual machines in a scale set. You don't define a public IP address for each virtual machine. Typically you would use a load balancer. You'd define a public IP address for that load balancer. Then in this case, if you wanted to connect to each virtual machine, you could define a set of inbound NAT rules for your load balancer. So then in this example, you've defined when a client comes in and connects to the load balancer, port 50,000 will map to port 22 on the first VM in the scale set. Port 50,001 will map to the second VM in the scale set. 50,002 will map to the third VM, port 22 in the scale set. So this way, if you define that, then basically you can just connect from a client using a single IP address to any virtual machine in the scale set. In fact, if we look at the virtual machine that I just went and deployed, that's exactly what I did. So here's an example. let's actually just go look at the template itself that I went and deployed. These are those parameters that I entered. There's a set of variables. I create a set of storage accounts in a loop, so I created 5 storage accounts. In future versions of VM Scale Sets, you won't have to do that. We'll have a feature known as managed storage, so that storage will purely just be a property of the scale set, and you won't have to go pre-create your storage accounts. So I define my virtual network. I defined a public IP address. Then I defined a load balancer, and then within this load balancer, I define these inbound NAT rules. So front-end port range start 50,000, back-end port 22, and that's how we enable this connectivity. So then this was my scale set definition. So I have the virtual machine profile. I define the containers where it's going to put the VHDs for each VM, and like I say, you won't have to do this in future versions, and in this case the container itself gets created. You just basically put in your storage account references, and then I define the network profile which links back to this load balancer. So that way, that's the whole scale set, and then this is where it created it. So here's my scale set, then here's my load balancer, and the scale set. Initially in the portal, we're not providing too many details. This will, you'll see gradually more details get provided in the portal, until eventually you'll get to the point where you can do everything inside the portal. You won't even need to create a template. You'll just be able to create a scale set directly from the portal. But for now, it's fairly primitive. At least it recognizes that scale sets are part of this part of your resource group. If I go and I can look at the load balancer. And I could go and look at the load balancing rules if I wanted to. Or what I will go and look at though is the public IP address. So here's my public IP address. So if I go to this public IP address, I can copy it, and then if I wanted to, I could then go connect to this public IP address and specify this port based on the NAT rules of 50,000. And that should take me to the first virtual machine in my scale set. So here it is. Sorry, it was in a different window. Here it is. This is the first virtual machine, and I could keep going. I could put 50,001, 50,002, etc. So that was the scale set that I deployed. I'll move on and describe a few more patterns, and then I'll look at some more ways I can actually explore this scale set that I deployed. So that's connecting. That's not the only way to connect though. Another way would be to define what you could call a jump box. In this case, you just define another virtual machine, in this case a standalone virtual machine in the same VNet as your scale set, and you could associate a public IP address with this virtual machine. Now in this diagram, it's set up with a Mesos master as a VM, so then you have like Mesos slaves as the scale sets. Of course it doesn't have to be, it could just be a VM that you've configured, and then from this VM you could then telnet or RDP into the VMs in your scale set which have private IP addresses. So in this example, yeah, if it was a Mesos master, you could use a browser, you could go to the public IP address, port 5050, and then you could go and do things with your scale set. That's two ways to connect. Another thing that you could do with a load balancer and a scale set is round robin load balancing. So in this kind of simple diagram, we've got 3 IIS web servers all listening on port 80, and then a load balancer will round robin the incoming connections to each VM in the scale set. This way you could distribute the load, and of course you could build this out. You could have multiple load balancers, you could have multiple VNets, you could use a traffic manager going to multiple load balancers. So there's various ways you could build this out into a very scalable solution with no single points of failure. So here's an example of chaining load balancers. So you could have an internal load balancer, a set of front ends inside your VNet, and then an external load balancer with a public IP address. So you could gradually build this out. As I mentioned, you could have a traffic manager, and a set of clients which then their incoming traffic is distributed between different scale sets with using internal load balancers with IP addresses, and that way you could be part of different VNets. And then autoscale. So here's kind of an overview diagram of how autoscale works. In this example, it's showing autoscale on Windows, where you install an extension called WAD, or the Windows Azure Diagnostics. You could do this on Linux as well, using LDE, the Linux Diagnostics extension. And what happens is these extensions, they emit usage data, which then gets compiled, and you can evaluate it against your autoscale results. So then basically the autoscale service and the monitoring service and the autoscale service can then decide whether to issue a scale action and change the number of virtual machines in your scale sets. This way you can integrate directly, or you could write your own autoscale layer. You could just check for whatever events that you want and issue those scale events yourself. So I've included a link in GitHub for an example of a scale set which autoscales. What about scripting? So far we've looked at templates and we've looked at the portal. What about if you just want to use PowerShell or the Azure CLI, the command line interface? So you can do that. In fact, you can do that with current versions just by deploying templates. So here's an example of where I deploy one of the templates that are in that same repo in GitHub. And then there's you can use different commands like new Azure resource group deployment, get Azure resource, to go deploy the scale set, and then you've got various options to get details back. So you could do a get, you could pipe it through convert to JSON with a depth of 10 to get more details, or you could add the debug argument to the command to get the full packet of information that comes back when you do a get on a scale set. And similarly, if I just want to scale up or down, you can you could use the same template, or you could use a different template that will just changes the capacity. And if you wanted to remove one, you could remove the whole resource group, or you could remove an individual resource. So there's a set of commands that you can use right now that manipulate templates in this way that you can use with scale sets. One word of caution is that some of these commands will change when we release Azure PowerShell v1, which is coming pretty soon, where some of these commands will then become, you'll put RM for resource manager in the command name. So some of these command names will change, but so just kind of treat these as an example. And similarly, we're working on a set of imperative commands where you can do things like refer to your VM scale set directly. You can create a scale set, you can get a scale set details, and you don't have to refer to a template or the resource type at all. It'll just be built-in PowerShell commands. So like I say, these are changing, but this just gives you an example of what you'll be able to do, and the current documentation will show you what the latest syntax is. Similarly with CLI, these are a set of CLI commands that manipulate templates, so you can go create a scale set in a very similar way that I went through with PowerShell. You could do a group deployment create and go create a VM scale set template. You can get the details in a similar way, and so it's basically same set of principles. And then we're also building VM scale set specific commands. So again, wait for more documentation and more information about these. I've really just included this slide just to note, yes, we will have VM scale set specific parameters. So this scale set we created, I mentioned in the portal that right now there's a limited set of detail. We will be increasing this steadily, so if you check the portal you may see more detail. Depends when you go and check, and you're welcome to check with me what the status of this is. But so right now the portal will recognize your scale set. Another way, and initially a much more effective way to go and explore your scale set, is to use the Azure Resource Explorer. So this is resources.azure.com, and let's look at the scale set that we created using this. So I'll go look at the Resource Explorer, and here I'm going to refresh, and here's this NatPools 2. that I created. Let's go and explore it. So I'm looking at the different compute providers. As I mentioned, Scale Sets are a resource under Microsoft Compute. So let's go take a look there. We've got virtual machine scale sets, and then we've got this scale set NatPools 2. And then, as you can see, this is the definition that we submitted. This is the definition of the scale set, and I can go and explore the virtual machines in this scale set. So here are the 5 virtual machines that were created, and then we can also go look at the network provider and see what's in there. We can see our load balancer. So our load balancer has all of the details that we used, the NAT rules, everything else, and then we've got our public IP address. So if I wanted to, I could get the public IP address from here. So the Resource Explorer is a very, very useful tool for exploring the resources that you create in Azure, and it even has, if you look at the details, it even has a PowerShell section, which will then show you could actually get the same information using PowerShell. Hopefully we'll have a CLI component for this as well, but right now at least it can give you the PowerShell commands. So that's exploring, and that's all for now. Please do contact me on Twitter if you have any questions or comments. You can take a look at some example scale set templates in our public GitHub repo, and thanks for watching.